So once again, ladies and gentlemen, thank you so much for logging into the Russ and Joe Developer Show. Today we're featuring Jeff Barnes, and they're going to be talking about the role of the software architect. Gentlemen, thanks so much for being with us today. You now have the floor.
Thanks a lot. This is Russ of the Russ and Joe Developer Show. I'm very excited about today's session here. I'm coming to you live from Newport Richey, Florida, where now it's actually up to 83 degrees. Sunny skies. It's a beautiful day down here, and looking forward to working with Jeff here. Jeff and I have worked quite a bit together, along with Joe. The three of us really tag team quite a bit down here in Florida, and I'm looking forward to learning more about the role of the software architect. And to me, one of the most challenging parts of that is spelling the word architect. I don't know if you have to know how to spell, Jeff, to be in this profession or not, but anyway, we'll come back to that one. And I just wanted to turn the floor over to Mr. Joe Healy so he can say hi to everybody. Joe and I will be managing the question queue and providing some insight as the show progresses. Joe?
Hey, this is Joe Healy of the Russ and Joe Developer Show. Russ, you don't have to spell architect if you're an architect, because all you really have to do is draw a picture of it. So very, very good stuff. It's the symbol meant to be the architect, not the actual architect implementation itself. So with that, we're pretty excited to have our Florida teammate and architect evangelist for the state of Florida, the great Jeff Barnes, presenting with us today. So, Jeff?
All right, hello, my name is Jeff Barnes, and as you guys have already heard, I'm an architect evangelist with Microsoft, and my little picture here demonstrates what Joe and Russ think I do all day, which is draw pictures on a little whiteboard. So today's session, we will dispel all those myths and actually go into the nuts and bolts of what it's all about to be successful as a software architect. So looking forward to today's session.
Great. Thanks, Jeff, once again for helping us out here. And I have a couple polling slides we're going to show you. A few questions we have. We'd like to get everybody to answer just to kind of what is your primary job role, if you can go ahead and specify that right now, whether you're a enterprise or solutions architect. And John, if you can please, there we go, show the results. That's good. And go ahead and click away on the choice that some reason is anybody able to click on that? John, I can't seem to click on that particular.
One person has voted. I can't click on it.
Oh, there we go. Now it's unlocked. Okay. There we go. Now we got the votes coming in. Oh, we got a good number of developers here that you can influence here, Jeff, today. And we have a good number of solutions architect as well.
Hey, Russ, Pierre Doniego from Southern Wine, South Florida says hi.
Oh, Pierre is on our he's a frequent flyer on the Russ and Joe Developer Show. We should start coming up with frequent flyer prizes, Joe, for repeat attendees.
That's interesting. We should.
I think you've got the Zune.
So here we got a good split, Jeff. Take a look at these results. We got a couple, 3 enterprise architects, 16 solutions, 1 infrastructure architect, a good number of developers. So really the primary split here in our audience today, for the most part, is between solution architect and developer. All right. So next question. We all love to know where you're from. So where are you from? We like to try to keep track of those that are right here in Florida, the rest of the U.S. East, U.S. Central, U.S. West, Canada, worldwide, just to kind of get a feel for who is from where, those listening in on this webcast. And we have a good split here for the East and Central, picking up the majority. We got some early risers out in the West Coast, Canada, and worldwide, hanging in there at about 5 or 6% each as well. So we got 4 or 5 tuning in, Joe, here from Florida. I know that's one of your things you're primarily interested in.
Horace is also from Miami, so we got Miami in the house. So we got 2 Miamiites, so pretty good.
Miami? Is that what you call it?
Yeah, I don't know what we call Miamians, but I'd point out Jeff's kind of shy on his self-promo, but he lives in Miami. He's also started a bunch of architect special interest groups that meet around FLA.net in South Florida. Go to his blog, and you'll be able to pick up all the cool things that he's got going on, and he definitely pounds into that South Florida area, sets up a lot of cool events for y'all down there. And we're working on our business plan for July to next June, and man, the gloves are taking off. We're going to have some awesome stuff coming down there, so So watch Jeff's blog, and you'll see a lot of stuff on South Florida activities.
All right, so for our final poll slide, and again, John, this doesn't seem to be live here. It's froze up. So if you can show the results and activate this poll slide. Are you considering a move toward a role of a software architect? And this is primarily geared toward those that responded they weren't already in the architect role. So either you're already in it or yes or no. And just kind of gives an idea of the interest level in perhaps, changing roles. It's good to mix it up once in a while in your career or supplement, with various activities other than straight old coding. All right, good number there, Jeff. So, Jeff, we're going to turn it over to you and let this get started, and you take it away, sir.
All right, so for Russ and Joe, who are primarily developer-oriented, I've got the agenda here expressed in code for you guys to better understand more easily.
Well, you demand.
So hopefully you guys catch that there. Actually, no, let's switch over to what the real agenda here is. We're going to talk about architecture and specifically software architects, and then go into some of the roles, responsibilities, some of the tools of the trade around frameworks and how to be successful in terms of gathering requirements, some of the other tools for design patterns, UML, etc., and then what it takes to be successful working on large projects, some of the roles that you might want to look at, how they're defined, project management, and then some other things to help ensure your success around being able to do automated builds and deploys and testing. And then finally we'll wrap up with some of what I found to be secrets to success in this category. So today I'm looking to really dispel a lot of the myths around what an architect does and what it takes to become a good one. So we'll start first with architecture and with the formal definition of what is software architecture. Here you see the IEEE definition of software architecture, that it's a fundamental organization of a system, embodied in its components, the relationships to each other and their environments, and the principles governing its design and evolution. A lot of words there in that definition, so let's kind of drill in on that to really find out what it's all about. It's really all about establishing the context for the design and implementation of the code. And there's a lot of decisions that go into that process, but at the utmost, that's what architecture is really all about. So why do we need software architecture? Basically two reasons. One is to deal with the size and complexity of modern software architectures, be able to decompose the problem, create abstractions and views, being able to integrate components, and then also look at, from a broad system perspective, what are the operational requirements? What are the failover redundancy requirements? And then how do you do prioritization and trade-offs as you go through the requirements to come up with a successful project that you can implement on time and on budget? So why is software so complex? Well, if you look at the domain today, there's all different types of technology in use and more that are emerging on the horizon. Commonly, it's been difficult to manage the development process. Developers and testers and so forth are a different breed from other folks in the business world. So being able to manage those teams effectively and get the job done within the constraints is a difficult process. The other thing is, software changes over time. All the technology that you start out with within a year is going to change. So these things are very fluid and a moving target as you go through these issues. Other things that add to the complexity is the sheer volume, in a lot of cases, of the requirements. A lot of times there's competing and contradictory requirements that you have to make trade-offs around. There's also non-functional requirements that the users and business analysts will forget to tell you, or that you need to define discreetly out of the requirements that you're giving. The other thing that happens commonly is requirements keep changing. It's hard to lock down on a fixed set of requirements to be able to deliver on those in a specified amount of time. It's also tough to communicate requirements from both sides, from the business to technical and vice versa. And then there's also external complexities around budgets and timing and software drag. So these are a lot of the things that add to the problem in terms of designing good software architectures. Excuse me. Some of the forces in software development as well, things around the common triangle of you have a fixed budget, time, and resources. Here's some other things that add to the problem. Excuse me one second. Excuse me. All right, so moving along, other things that add to the problem is when you consider
Hey, Jeff, while you're getting a drink of water there, we did get one question in, and let me read it off to you, see if you can lend some light on this. It says, from Bill, what architecture tools are offered by the Microsoft Teams Suite? I don't know if you can be talking about that at all today. And what useful architect tools are missing or better handled by third-party add-ons?
So I'm going to keep the conversation relatively technology agnostic. I'm not going to go into the tools necessarily in Visual Studio Team Suite today. I'm basically going to talk about the architecture domain in general, and we can schedule that for follow-up, but I'm going to probably be more agnostic in terms of the tools and technology today to answer that question.
All right, I'll have him drop us an email, and we'll follow up more on that.
Sounds good. All right, so the other thing that in today's world, if you look at distributed systems, the complexity goes up many, many times over. Things like application responsiveness, being able to layer your application, consider online and offline characteristics, network latency, how you do serialization over the wire. All these things add to the complexity more so than ever, especially when you consider the traditional monolithic systems of the past. The other thing that makes it difficult is managing the development process, right? The whole notion of software development as a team sport and how do you get the most out of every player. The other complexity is the multiple language issues and platforms, different processes, architectures, and tools. So all of these add to the equation of difficulty in creating architectures and implementing them in today's world. So a lot of times people consider that software architecture is like building a house. However, it's actually very different in a lot of ways. For one, there's no equivalent laws of physics, right? Building a house and engineering structures have been a known entity way back from the pyramids. Today, in the world of software architecture, things are a lot more complex, as we just saw. There's a lot more changes in requirements and technology churn, and the fact that you can produce software and get it out there so cheaply and distribute it makes it a lot more complicated in terms of dealing with the issues at hand. So let's talk about software architects for a second. And I love this quote from Alan Cooper about the role of the architect. And he states, today web designers are called programmers, programmers are called engineers, engineers are called architects, and architects never get called. A lot of times that's very true. Working in the consulting arena, I found that there were commonly two reasons I would get called into an engagement. One of them, which was the best case, was people were going to look at designing a new system from scratch, wanted the best help in terms of the right ways to do things, etc., for performance and scalability. And on the alternate side, most of the times we were called in because somebody hadn't taken all those precautions, put a system into production, and now they were having problems and losing a lot of money by the hour. So obviously architecture up front adds a lot to the equation.
There's a couple questions which will fit in this dialogue. First one was a comment on like architects using design patterns, and then who do you consider some of the best software architects of all time? Would you put someone like Zachman as a software architect?
So I've got some slides on that later on in the presentation. We'll talk about some of those frameworks. You know, if I was to say who was probably one of the best architects in the world, ironically, you know, you look at the Egyptians who built the pyramids. The mathematical precision based on the tools they had at the day, pretty remarkable. And the fact that it's still standing is also very remarkable. And I know that we weren't going to use that analogy of building and engineering as a comparison in the architecture world, but if you think about it, that's an interesting concept there. All right, so let's keep diving in here. What is a software architect? In a lot of ways, it's a mixture of these different roles, right? A politician, technologist, evangelist, author, project manager, mentor, psychiatrist, psychologist, all of the above. So there's many different facets to this role, and a lot of different organizations implement architecture in different ways, but I find these are common attributes that you'll find across the board. So an architect defined, right, it's not just a top-level designer or developer. They need to have skin in the game. They just can't come through, look at the requirements, and bless them or not. They need to be involved in the process. In terms of project manager, they need to be joined at the hip. They need to be able to influence and affect the schedule that comes out of a project manager's workbench and be able to add reality to the equation. They're not necessarily the technology expert, but they need to know how the systems work together and how components fit in with each other. And they can't be a lone wolf. They need to be good communicators and leaders in order to be effective. So why are architects important? Well, for one, they influence a lot of things like application development standards, platform decisions, tools, operations, CIOs and executive officers, and they tend to think a little bit more strategically around their role. So why do we need software architects? Well, if you think about what's the purpose of IT, it's to make business processes more efficient. So the role of the architect is then to, around those guidelines, simplify the complicated, develop software that delivers required business functionality, mapping these requirements against technical capabilities, and then produce software that meets all the quote-unquote abilities. We'll talk about that in a little bit. And then the other is to actually try to maximize the application life expectancy. Software development projects are a huge investment, so anything you can do to help make that investment last longer is worth it, your money there. So if we look at the food chain of architects, we see that at the top we've got the CXO, CTO types, and then we've got the enterprise architect that sits across infrastructure and solutions to be able to give a holistic view of how software should be implemented in an enterprise. And then beneath that we have the software solution architects, primarily surround the application development, and infrastructure architects in terms of the machinery and software to run the network data centers. And then beneath that we have the developer community and IT professionals. So if we look at, we did a study a couple years ago, how many full-time architects were there in the U.S. And across the U.S., in terms of folks that said, this is, yes, my full-time job, we found that there were about 83,000 architects out there in the wild that said this is their primary job role and responsibility. And then the other interesting fact was, if you look at how many part-time architects, almost 200,000.
Wow.
So what you really see here is a lot of folks have dual roles. Architecture is just one of the many hats they wear and job responsibilities. There's quite a few different flavors of that as well.
Jeff, part of my career I was involved more, in an architect role. I hate to admit it to Joe because I don't want to break his heart on this one, but
you're just giving me ammo, Russ. You're just giving me ammo.
And these numbers are very, very large. Would you say these folks are probably, have the attribute of being, one of the key decision makers in the organization as well? The trendsetters, that type of individual.
Sure, and it also, can vary by the company size. You find in smaller companies, people wear a lot of different hats, and so they have more influence on the decisions up and down the food chain. So, absolutely. So I got a couple more slides on this. If you look at the different roles that apply architecture, you'll see that, again, it's across the board between systems engineers, developers, developer managers, even database. In the database world, you have architects, and in the web world as well. So here's a look at some of the common titles that can also hold the role of architect. And a lot of these titles, as you'll notice, don't even have the word architect in them. So, architecture's been a very difficult role to define and come up with common standards of measuring. But what you do find is that there's key characteristics of good architects. And one of those primarily is around soft skills, being able to listen, negotiate, facilitate, being able to get involved with project management and influence schedules and so forth. Communications are huge, both verbal and written. And then empathy, making sure that we're not putting the whole team on a 3-year death march to get something done. And now here's another bullet point I want to draw your attention to, and that is that one of the most common methods of evaluating architect performance is successful implementation of projects. And this is a key quote here, and when you think about it, a lot of architects are judged whether the project was successful or not, whether or not circumstances beyond their control led to the demise or success of the project. But one common way of measuring folks is around that one measurement. So that's pretty interesting. Then when you look at the top challenges facing architects today, you'll notice that integration is the top challenge that's come across, as well as the number 3rd, which is justifying the business value of IT and the ROI. what you see is this takes up a lot of their time in terms of being able to handle the politics and thinking for coming up with strategic systems. A couple other observations. Solution architects are very similar to developers, but tend to be more project-focused. One analogy I use quite often is the forest and the trees, right? If the developers are mostly focused on, hey, how do I cut down this tree in the forest? What's the best tools, saws, etc. The architect may be more focused on, okay, is this the right path through the forest? How do we bridge the river? Is this even the right forest to be chopping down? Those types of things. So just a little bit wider expanse of what's going on. And I think by the fact that there's so many on the webcast today and a lot of interest in this, architects are always looking for validation of their profession. And there's several organizations out there today that are working towards this, including Microsoft. We'll talk about that a little bit later in the deck here. And as we already saw, a lot of architects are part-time, but other job responsibilities are often required. And then finally, integration and interoperability are extremely important in terms of today's landscape for architects. So the other thing is, as you look at a common project timeline, the architect's focus over time changes from the early stages when you might be heavily involved in requirements, and then definitely in the architecture and design of the project, and then implementation as things are rolled out into production, making sure that the network operations data center guys can manage these things remotely, etc. So let's shift gears. Let's talk about architect responsibilities for a little bit. So what is the software architect responsible for, right? A 900-page requirements document, maybe a large, complicated Visio diagram, all of the code, delivering the project on time, 0 defects, everything. And I know Joe and Russ, you guys are going to laugh, but a lot of times the architect wears the bullseye for the project. Do you guys find that to be true?
Yes, absolutely.
It's interesting. It's hard to define exactly what an architect does, but you can definitely say that a lot of the responsibility rides on the shoulder. So when you look at some of the common responsibilities, defining and validating the architecture is one, maintaining the conceptual integrity, and primarily looking at risks and identifying them and attacking them early is key to success. And then being able to go and mentor team members, facilitate project management, all those things are common responsibilities that you'll find in the architect role. So if you look at the life cycle, what you'll find is a lot of times architects are involved with the key business and IT strategy projects, and a lot of times the life cycle will be they'll take 1 or 2 big runs defining an enterprise architecture for a corporation, and then they'll spend a lot more time on individual projects implementing those different architectures and refining them as you go along. So that's kind of how we see the life cycle of architects working. So we're going to shift gears for a second here and talk about some of the common architectural frameworks. Somebody had an earlier question on the webcast about this. And so when you think about architectural approaches, right, you think about common frameworks that allow you to have multiple viewpoints that take into account the interests of IT, of the business, and the operations folks, and enable the solution to map to many different dimensions of the key stakeholders in a project. So a couple of the more classical architectural views out there, use cases. This is very valuable in terms of being able to identify behavior of the application. Then you have different views around logical, where you basically define where a system is developed, used, or deployed, process views, how things are going to work within components and between components, how the implementation of the system is going to be handled, and then finally deployment, how are updates and version control issues going to be handled throughout the software lifecycle. All right, so let's shift gears and talk about some of the architectural approaches. So a couple of the famous ones is Open Distributed Processing, which is also known as ODP. And they have a 5-viewpoint reference model that takes into account the enterprise, the informational, computational, engineering, and technology aspects. It's an ISO standard and supports object-oriented concepts. Another one that's quite famous is the 4+1 view model by Rational. And again, taking into account different viewpoints here, logical, implementation, process, and deployment. and then also including use cases as well to describe those. Then we also have the granddaddy of them all, the Zachman framework. This is a traditional approach, which is a matrix combined of about 30 different architectural viewpoints. And all these viewpoints are meant to consider the stakeholder impacts. Because this is from the earlier days of software engineering, there's really no object-oriented support, but here's a look at what the Zachman framework would look like. And you see kind of here a matrix between the different layers of technology implementation and the different stakeholders, etc. So this is just kind of a background of some of the frameworks that are out there to help you get started. So let's shift gears and talk about gathering requirements. When you look at software development, this is one of the key aspects of a successful project, is being able to gather requirements correctly and be able to diffuse through them to ultimately determine what the correct implementation needs to be.
Hey, Jeff.
Yes.
One quick question from Bill here. What impact does agile development have on the architect's role and involvement?
So working towards that, I'm going to actually show the difference between traditional waterfall and agile approaches here in the next
beautiful,
couple slides.
Okay.
So, great questions. Stay tuned here. We're getting to them. So as we look at some of the levels of requirements, right, things around the business requirements usually sprout up first, and really if it's the notion of an athletic game, right, what game are we playing in the context of what is the things that we need to define in terms of requirements. And then from the user aspect, who are the actors and what different roles do they play in the application? And as part of this, we start creating use case documents to further define those things. And then finally, how does this all come together in an application or a system in terms of deriving what are the functional requirements that we need to build an application to handle. So there's typically two types of requirements, these that are defined as functional, that typically you're going to derive from your business requirements analysis, and your business analysts and key stakeholders are going to help communicate these things. But then there's also another dimension to it, which are the non-functional requirements. Things like business rules that need to be inferred from different processes, quality attributes around the user in terms of system responsive time and page refresh, those types of things. And then external interfaces in terms of availability of those interfaces. Maybe there's constraints on how often the system can be brought down or not. And all these things come together to define the two basic types of requirements around functional and non-functional requirements. So some of the classic non-functional requirements, and typically you talk about them with the phrase of the abilities: scalability, reliability, deployability, manageability, extensibility, along with the ability to secure the application and process, as well as, very important, the ability to upgrade it when the time comes to add new features and functionality. So if you look at some of the architect's tools, the classic tools that an architect would use to help define in the early days of project management lifecycle, the typical Office tools, Office Word, Visio for diagrams, Excel, a lot of times for doing estimations and work plans. Project is a classic. PowerPoint is useful for conveying information to users and executive management. A lot of times UML is also used to be able to describe how processes need to work. And a lot of times they'll use third-party modeling software. So obviously this would be a play for where we could use tools like Visual Studio Team System or other applications that help you model applications for better communication and implementation.
Sorry, Jeff, one more question before you get into design patterns. We had a question here on are there any free tools for things like gathering requirements, use cases, etc., that should come to the top of your head?
No, I haven't seen any free tools per se. And so, I'd be open to hear some of the tools you guys have heard about out there. But a lot of times, they're going to go with software that you need to pay for. So there's probably a few out there, but none of them come to mind at this point. All right, so let's move on to design patterns. So one of the most common is layering an application, being able to separate the user interface, the presentation logic from the business logic, from the data management tiers. And so there's definitely several benefits, right? I can encapsulate similar functionality. I can encourage reuse of components. I can minimize dependencies. So it's just a good best practice that we've seen throughout the years in terms of building software. The next slide this is our classic application architecture slide that you will see off the Patterns and Practices site on Msdn, where we have different layers for the application, the UI, the business logic, service interfaces, and then ultimately near the bottom, data access and service agents. And then around each one of these layers, you also will see security and management and communication also intertwined. So let's look at some of the things that help us build applications and systems. And one of those is design patterns. And it's been said in the past that design patterns are the soul of an architecture. And I do believe that because it's basically a great way to come up with common abstract solutions to common problems, to be able to reuse these things over time. So one of the most famous that you've probably heard of is the model view controller pattern, and we'll talk through some of those as well here. So in addition to patterns, there's also things called anti-patterns. And so these are more about best practices for what not to do. They're recipes for disaster. So just as valuable as patterns, a lot of times anti-patterns can also add to the equation and help you avoid certain train wrecks. Here again is another one of my famous quotes here, that no program is totally worthless. It can always be used as a good example of bad programming.
What do we actually call those quotes?
Those are JB-isms, and actually
architect-isms. Architect evangelist-isms.
I think, Joe, this came because I was reviewing one of your code samples one day, but anyway, we'll go on here. So looking at some of the common design patterns that are out there, there's one called the Gang of Four, which I encourage you to look at, which is fairly common, and it's basically categorized into 3 different groups around creational, structural, and behavioral patterns. So we'll take a quick tour through there. So here are some of the creational patterns that you'll see, especially if you're looking at any of the service factory concepts that you'll see off of Msdn or other software technologies. You'll see a lot of these in terms of abstract factories, builder patterns, factory patterns, etc. So some more around structural patterns. There's the adapter, bridge, composite, decorator. Facade is used quite a bit in order to obfuscate some of the back-end services. And then you have several different behavioral patterns that also go along here. Chain of responsibility, interpreter, iterator, etc. And then finally some more around observer, template method, and visitor. So I encourage you to go out and look at the Gang of Four patterns that are out there and see what you can glean from those in terms of your own software projects to help integrate these things.
Hey, Jeff, give your voice a rest there for just a second, take a sip of water. And I just want to let everybody know this is a great deck and a lot of wealth of information in here. And feel free to print as a PDF. Under the File menu pull down, there's a Print to PDF option, and you can have all this great info. All right, Jeff, go ahead.
All right, thanks. So, in an hour, it's hard to go into any kind of depth here, and so what I'm trying to do is paint a very broad picture of the things that an architect would want to consider, and to give you some pointers in terms of places to go for more information. So the next thing I want to talk about is frameworks, right? And what are frameworks? Basically, they are the composition of patterns into larger scale implementations that allow you to create templates for applications. And if you guys are in tune today, later on I've got another session coming up on the Web Service Software Factory, where we're going to use a framework to implement web services using with this communication foundation using exactly this approach. So some of the sample patterns that you would find out there that are common in these types of frameworks, again, are the model view controller for handling complex user interface interactions, call and return systems, data flow, and data-centered systems. So those are some of the common frameworks out there. Some other ones you probably heard of are the Microsoft.NET Framework Enterprise Library. It's actually now up to version 3.0. If you go out to Microsoft.com/patterns, you'll see links to this. There's also CSLA, which was originally designed by Rocky Lahatka. There's ACA.NET by Avinod. Other ones, Apache struts, Ruby on Rails, and many more that are out there today. So let's shift gears and talk about UML for a second. So UML is very beneficial in terms of being able to capture requirements, and there's really several benefits here. One is, above all, being able to communicate with clients. So you basically have a common picture that both sides can understand in terms of how the application needs to interoperate with users and with other parts of the application. It also helps to define the requirements. If we can draw these things out using these UML diagrams, it makes it much easier to define the requirements, as well as generate test cases. If you know ahead of time how the system is going to work, you can get your QA and test resources working on generating test cases from these artifacts. So in UML, it's basically broken down between structure diagrams, and you'll see some of the more popular ones here, and interaction diagrams. And we'll go through these here and show a couple samples. And overall, there's about 13 core UML design patterns. So we'll look at some of the classic ones. First one here is a UML class diagram, which basically shows the relationships between classes and components within an architecture. The next one is a component diagram, where it would show interface points both externally and internally, persistence, etc., and boundaries between components in an application. Another one is activity diagrams, where I kind of have this state machine that goes through and defines, sequentially, here's what would happen based on certain inputs and outputs and what the next step would be. Another good one is these sequence diagrams, which is commonly referred to as the swim lanes. So what you see is these swim lanes in the middle of the diagram with different responsibilities, and as a application goes through these different boundaries, you see the interactions. Another one that I find used quite a bit are use case diagrams. These are very effective at spelling out the functionality of applications from an actor's viewpoint, an actor being the user in this case. So of all the UML diagrams, I would definitely look at use case diagrams primarily as one of the best in terms of being able to gather requirements. So another key aspect that a good architect needs to have under his belt is database knowledge around how to create databases from the schema, what the proper way to handle indexes and tables, more complex things around distributed partition views, maybe being able to incorporate the common language runtime in the event that you're using SQL Server 2005. Normalization is also key, being able to make sure that you don't have redundant data in your database schema. But there's also times when it actually makes more sense to denormalize your data versus normalize it to get better performance. Another key aspect is transaction management, knowing how to handle ACID-type transactions with the correct atomicity, consistency, isolation, and durability. Concurrency is also huge, being able to handle pessimistic versus optimistic locking, also things around data warehousing, OLAP technology and cubes, being able to understand ETL tools to be able to take data from one database to another and transform it all along the way. And another thing is performance techniques, being able to optimize and test your database, because when it comes down to it, a lot of times the most pressing performance and scalability issues can be traced right back to the database. So having good skills in this area is a key factor for successful architecture. So shifting gears a little bit, talk about the art of software estimation. And I really do believe this is an art for a lot of reasons. And if you think about it, it's really one of the most critical aspects of software development, because it becomes the measuring stick for success or failure. A lot of times people will evaluate, again, whether the project is successful or not based on whether we hit the deadline. So software estimation is huge in terms of being able to predict that successfully and come out on top. So some of the keys to success that I found is being able to split the tasks up by functional skill sets, being able to do a bottoms-up work breakdown to come up with some really granular estimates for software, being able to do a reality check for task durations, making sure that you're not considering as if you were doing all the coding, that a normal developer would be working at the normal pace. So what I found is that the more granular you can get these task breakdowns, the better your effort estimates are going to be over time. And then, so here's just a quick look at how you might structure a worksheet or something to be able to go through and create these breakdowns. And basically you just try to define the tasks in as low as possible and come up with reasonable estimates. Here's another view with a spreadsheet in terms of, you know, how you might come up with these estimates based on different factors in terms of, you know, is it a fixed number of hours to do something, what's the complexity, and how many hours it might take to do something. Another thing I found is that milestones are key to be able to communicate with management what you're going to deliver and when, and as well to manage whether the project is on track or off track. So typically what you want to do is break down your project so that you have short deliverables, typically every 1 or 2 weeks, and in addition to delivering the code, having another overlay for what the testing approach is going to be, both in terms of unit and functionality testing and stress testing as well, and then also figuring in user acceptance testing along the way so that you get that user feedback.
Jeff?
Sure.
Got an interesting kind of a discussion point here from Karen. She wants to know, in your opinion, what is more important for a good architect, someone like perhaps Steve Jobs, whose strength is the vision thing, arguably right brain stuff, and the more rigorous left brain engineering approach?
I think both are important because in the end you're not going to get a good result unless you have both a good vision and then people who know how to make that vision a reality. So sorry, but I'm not going to take one over the other. I'm going to say both are equally important. And I'll give you the classic consulting answer. It depends.
Yeah, right.
So I think both are equally important, actually. And to be
so
honest,
you got another question over there?
This is an interesting one. Jeff, you've been plugging UML and sequence diagrams a lot, but that's inherently not a Visual Studio Team system. So what are you recommending folks use there?
So just because UML isn't necessarily in Visual Studio Team system doesn't mean it's not a good tool to use. So I still think that having diagram communications between what user requirements are make a lot of sense. So a lot of times, in terms of a tool, you can use, there's some UML diagram shapes in Visio that work. And I will say that, not everything you need to be successful is contained in Visual Studio Team System. We're working towards that end goal, but not there yet.
Borland has an add-in, too, that does UML in Visual Studio Team System.
Yep, that's true. All right, so moving on to development methodologies. So now we're kind of talking about, okay, I've gone through the requirements phase, gotten my project plan, I've done my estimates, so now we're talking about getting into the construction stage, right? So when you look at the development life cycle, right, we move from having a vision and a business case justification, the requirements, the technical design are done. We're now into the construction and testing stage. And so what are the key things here to make this successful? So we're going to walk through these here in terms of what I found to be good pointers in this space.
What's a distributed partition view of a database?
A distributed partition view allows you to create a logical table over database tables that may be separated out over multiple machines. So for more information, I would point you at the Msdn website for more details there. So let's talk about development methodologies. So why do we have methodologies? Well, basically they're techniques to improve productivity. The end game is to produce fewer defects, quicker delivery, and achieve better results. And around this, there's been three main schools of thought. What we find is the traditional large-scale project implementations where they use a waterfall approach, more agile approaches for highly iterative and smaller projects, and then something called extreme, which is where you would use team-based iterative short cycles. We'll take a look at each one of these in turn. So the waterfall approach is, the big project approach where you would typically have all of your requirements defined up front, and they'd be signed off by executive management, and you would have clear orders in terms of exactly how the system is to look and feel and work, and you start working after you've created that vision, constructing it in different phases. There's a hybrid approach here where they've created a spiral methodology to try to speed things up in this waterfall approach so that you can achieve parallel steps and rapid prototyping along the way. But this is the most traditional methodology approach that you'll find out there, and a lot of times in the consulting world, this is the typical type of project, because in order to estimate correctly, you need to know what all the requirements are up front. So then the next one you want to look at is agile software development. So there's been a manifesto published by the agile folks that value certain things like that individuals and interactions are valued over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. So these values are all around being very agile, working one-on-one with your user base and customers to do very iterative, responsive programming with the users heavily involved. So another flavor of this is extreme development, where you work in very small groups, again, you're using a lot of the agile techniques for very iterative development, just-in-time planning, and so forth. And then the implementation, you do a lot of pair programming, where you have two people at one keyboard. And the notion here is that in a one workday, they'll actually produce more than two separate folks at their own keyboards. I haven't seen this done in practice very much, but I understand that it is very effective. Another common practice here is to be able to write all the test cases first and then code to pass those test cases. So that's another look at a very extreme methodology here. So depending on the methodology you use, both or all three are good. And what you find is it's all about where you attack risk in the process. What you'll find is that the waterfall approach doesn't necessarily attack risk up front as much as an iterative approach like the extreme or the agile development process. So when you look at risk, that is the number one thing that will get architects, and something you should always be very aware of. So again, process best practices: attack major risks early and continuously, or else they will attack you. If I can give you no other advice than that, I will say that that is number one. You should have no unknowns in your project in terms of requirements or how to deliver it in your application. Other best practices: make sure you're delivering value to your customer. That also assumes you know who your customer is. A lot of times when you're getting all your requirements, you may not know who the exact stakeholder is. Have a maniacal focus on working software. Being able to accommodate change early in the process is also key. And then also come up with your architecture earlier on versus trying to bolt something on afterwards makes it a lot easier to do. And make quality a way of life, not an afterthought. So there's this notion of software factories, and if you're interested in this, I encourage you. I've got another webcast coming up in about an hour and a half where we're going to talk about the web service software factory. But what it is basically a guidance package in the context of the developer's workbench. Think of it as today we have reams and reams of documentation and diagrams that might be printed out and put on walls, etc. But this is guidance that's in the development environment. Including recipes, so I can run code generation tools to be able to create certain things that I'm going to use in my application over and over, so that I'm free to actually implement the core business logic at hand that is unique to the application. So some of the things around this, I've got a build-up slide here. What you'll see is we've created software factories that allow you to primarily your majority of your work is going to be done through configuration of different options in the package, and that leaves you the time to do all the handcrafting of the application-specific business logic that you need to do to implement the functionality of your application. I think you're going to see more and more this becomes a more common topic as we move forward in the IT industry, using software factories and this notion of domain-specific languages to be able to accomplish these tasks. So let's switch gears. Let's talk about team project roles in terms of an implementation. So these are some of the typical project roles if you're using the Microsoft Solutions Framework. We have different roles in a project, things like program management, product management, user experience, release management, testing, and development. And a lot of times the same person can wear the same hat here. It doesn't mean these are all separate people doing these things. For larger projects, you may also need to create sub-teams to handle different feature sets. And within those sub-teams, you'll also have these teams handling these different roles and so forth. So project management, this is another key aspect to being successful. So working with your project manager to make sure that the schedule is done correctly, based again on the estimates. Doing status reporting regularly is also key for making sure your stakeholders don't have any missed information or that there's any kind of conflicts there. Risk management is huge. Being able to identify and drive resolution to outstanding risks is an ongoing process. Change control as well is key to making sure that you don't interrupt software processes that are in place. And again, resource assignment and budget management are also key to this picture. In a lot of organizations, I'll see these two roles separated, the architect role from the project management role. But I firmly believe that to be successful, these two roles need to be very intertwined and that one can't operate successfully without the other. So if you look at the development schedules between iterative and incremental development activities, what you'll find is that the more agile approaches will tackle some of these things earlier on in the project, whereas the waterfall project will probably take a lot longer and tackle some of these things later on. So another key thing is to be able to constantly estimate and manage your burn rates, especially if you're using consultants. So when I say burn, I mean dollars burned per week or per month on consulting or IT expenses. So having an eye towards what it's actually costing the business to develop the software and be able to understand what resources are going to come on when to do what types of things, how many hours they're going to spend, etc., who's going to do project management over the many weeks and months it may take to produce the application. This is key, and be able to communicate this stuff consistently to your stakeholders is also key. Another key capability is to be able to communicate status effectively. I strongly encourage everybody to think about reporting on a weekly basis, report things like accomplishments, your plans, issues, and budget, and then progress against use cases or milestones. I find that if you communicate according to the milestones you defined previously, it helps everybody understand in a lot easier fashion where you are in the project. So another thing, if we switch to build and deploy now, I'm actually constructing my software, and how do I create an application that will help me test my development process as I go. So one of the things that I'm very, very high on is be able to establish an automated build and deployment environment early on in your project. And the reasons for this is to allow you to establish confidence in your code base and the process, automate unit testing and regression testing, make sure your deployment scripts work correctly, and then to actually simulate application and data migrations. If you can every day do an automated build and deploy of your application, maybe you're starting a new website and the first thing you're doing is adding a menu. And, well, I can automate that so I can produce all my code and deploy it to a web server so I can see my menu. I always know where I am in my process. I always know what code base works, and at the point that I actually break the code base. So it's a very effective tool. A lot of folks don't think about this up front, but I found in my experience this is a great tool to make an investment on early and often in projects. So if you look at some of the common activities in a build automation, things like I would take the code from an integrated server, I would create a new ID, I would create an actual build of the code, I would look for any code that didn't compile, I might look at some work items that were fixed through this code base, I might calculate code coverage, right? How much of my code am I generating unit tests for out of the entire population of my code in terms of methods, etc. So these are some of the common things that you'd want to look at for build automation as well as deployment. Another thing that a lot of people don't consider is not just the code but also the database aspects, right? Being able to know that I can also build and deploy a new database for my system. Maybe I'm modifying a database that's in production. So every time when I do an automated build, not only do I build my code, but I also practice doing the implementation of changing schemas and adding new tables and store procedures to a database so that when the automated build for the code and database is done, I can run full unit regression testing over it to know that it works. So speaking of regression testing, let's talk about some of the testing pieces here to success, right? There's different flavors here, right? Unit tests to make sure that methods work correctly in your code. These are huge if you can automate these. There's several tools out there. There's N units or J units. Visual Studio Team Test also has the ability to do this. Another aspect is being able to do stress and performance testing for things like web applications. User acceptance testing, maybe these are scripts that you run through from a user's or actor's perspective. Regression testing is huge to make sure you haven't introduced any new errors. And integration testing throughout your system. The key here is automation. The more you can automate, the better you're off you're going to be, especially when you talk about regression testing. So, secrets to success. Here's a couple things that I found in my role as a consultant, software architect that will help you be more successful. There's two main aspects, right? One is the technical side of things, making things work, making sure you meet the requirements and objectives, that you're implementing the code correctly, you're encouraging reuse, etc. And the second aspect is organizational, making it happen. This means improving communications among your stakeholders, providing the right context, making sure everybody is on the same page, and then working through the project management issues to make sure you're on time, on budget, etc. So some of the common points of friction, startup lags. A lot of people underestimate how long it actually takes to get up and going with a software project, especially when you consider I've got to acquire hardware and software, etc. Collaboration between teams, communication breakdowns, vacation, technology maybe that doesn't work. All these things come into play that you have to actually think about when you're estimating and managing these projects. So a couple important skills for architects. Obviously technical leadership is one, understanding the software development process, definitely knowing the business domain as well as your key stakeholders is key. Being able to take advantage of current technology trends, design, programming skills, communication skills are huge. And finally, the ability to negotiate. A lot of times you're going to need to negotiate features and functions in order to be successful, so it's huge. So Microsoft has something called the Microsoft Certified Architect program that we're starting with, and if you're looking for more information on that program, I encourage you to go out to www.microsoft.com/learning/MCP/architect, and you'll see information about the Microsoft Certified Architect program. But these are the 7 main competencies that are measured in that program. Technology depth and breadth, obviously, you need to have under your belt. Strategy, the ability to design a system and instantiate the enterprise architecture. Leadership, communication, organizational dynamics, and tactical process. Being able to make sure everything runs on a day-to-day basis. Some key points about leadership. Team leadership is an art, not a science. Try to protect your team from distractions. Manage them as individuals. Try not to micromanage. This is one of the other downfalls that a lot of times happens. Try to facilitate conflicts and keep things going. Communications is huge. Some lessons learned here. Technology is the easy part. Working well with your key stakeholders is the real challenge and reward. Serve your team. Listen first. Listen to what's going on. Knowing how to handle politics. Having a plan, thinking one step ahead of the game, and always trying to be realistic. Remembering that risk is always the enemy, and you should never have any unknowns in your project or try to eliminate them as fast as you can. And lastly, knowing who your constituents are to learn how to become more aware of when you're stepping on their territory. These can be people within your own team or in the business, etc., but finding out how best to work with them is the key. Some career advice: keep your technical skills current always. Always seek to increase the areas of responsibility. Try to gain additional technical experience. Gather some scars and gray hair by taking on a few things, and don't be afraid to fail. And always learn from your mistakes, right? There's a great quote that says, "Wise men make mistakes and fools repeat them." And then try to gain confidence via your own research so that you have the ability to know that things are going to work, especially with new technology. Some words to live by that I found very effective. adopt the U.S. nuclear arms policy, which is trust but verify. A lot of times you'll hear a developer say, hey, it works on my machine, right? Well, that's fine. Make sure it works on your build or deploy machine as well. Another one is there's a guy named Murphy that's always playing a role on every project.
Good old Murphy.
Good old Murphy. Make sure he's not the team lead. And so here's one that I find embodies the spirit of an architect. I am not the pearl. I am that tiny piece of grit and sand that irritates the oyster and causes it to make the pearl. That's a famous quote there by Ross Perot. So if you're looking for more information, I encourage you to take the next steps. Try to volunteer for additional responsibilities if you're one of those that's looking to get into the architecture space. Try to seek additional real-world technical experiences, research and find ways to exploit new technologies. Look at obtaining certification credentials in this space. Continue your formal study, and try to find a mentor. All right, so at this point, I'm going to switch it over to Q&A mode here. So if you have a question, please use the question manager. I know we've had a few already. So
yeah, Jeff, I've got about 6 questions total in the queue here to go through. What I would like to do is just go over a couple of community events before we wrap up, and then turn it over to John. John, I was wondering if you could just keep the audio live for these 6 questions that we can answer them as soon as we get done. Is that okay, John?
Absolutely, be happy to.
All right. So in terms of Msdn resources, I just want to make sure everyone's aware of the Msdn site. If you have not been out there lately, I encourage you to go out and visit. It's always being updated and enhanced. In particular, the Msdn Flash. That's how you find out about local developer events. There's always a local piece at the bottom of the Msdn Flash. That's a newsletter that comes through every 2 weeks. If you haven't done so, please sign up. In Florida here, we have a lot of great user groups. Really, the bottom 2 URLs, my site, russtoolshed.net, and Joe's site, deadfish.net, has links to all the user groups in the state of Florida and Mississippi and Alabama. And then also we have other webcasts coming up here. I know, Jeff, you're going to be doing the Web Service Factory using WCF in about an hour or so at 2 o'clock Eastern Time. Also, we've got other ones coming up you can see here. I've got these all listed on my website as well. And then also on the next weekend, next week, Jeff's going to be back again with us on Monday again at noon and at 2 for a couple more great webcasts and RFID Solution Stack. I can't wait for that one. That just looks totally interesting. And a Dinner Now demoing all facets of the .NET 3.0 framework. Just a really great demo. Hopefully you can all join us there. Then we got a few other ones on VSTA and VSTO. We've done a couple in the last couple weeks on ASP.NET, the Ajax from scratch and Virtual Worth. You can see the reg links on my site for those. Those have been recorded, so that's why I put those up there. Florida Code Camp's coming up July 14th. Go out to TampaCodeCamp.com. Deadfish.net's got info on the Jacksonville and the Tallahassee Code Camps. And then finally, MSDN events in August through September. This is not just a local thing. This is nationwide. I do have a few dates that are penciled in yet, but not firmed up. As soon as they are, I will put them up on my website. But these are half-day free seminars coming to all parts of the country, in the U.S. here anyway. And then also, if we go out to msdnevents.com, you can see more information about that. We've got 3 great topics coming up: Silverlight, Link, and then also WCF. So that's going to be a great session. I'm going to go back over here and turn it over to John briefly. And as soon as John gets done going over the wrap-up here, John, put the audio back on us, and we'll go ahead and blow through. It looks like we've got about 9 questions total now in the queue, okay?
Great. Thanks so much, guys. Appreciate it. Ladies and gentlemen, I will be very quick here. We're going to go ahead, as you said, we're going to go back to that, questions in just a second. But first, I want to get the evaluation up on the screen, so hopefully you can take a look at that and possibly fill it out while you are listening to the questions being answered. So, I wanted to remind everybody when that evaluation does come up, if you do take the moment, a little bit of time to fill it out and let us know what you thought of the webcast today, by submitting that, your name will automatically be entered for the possibility to win a Microsoft Zune digital media player. We give away several of these during the month, so could, as I said at the top, a possible added benefit for you there. Now, real quickly, let me just flip slides here.
For upcoming and previously live webcasts, I just want to remind everybody, www.microsoft.com webcast. Our entire catalog of webcast content is available at that location. Additionally, you can also find this webcast at that location probably within about 24 hours. You'll be able to stream it or download it for offline viewing. If you have webcast content ideas, if there's something you'd like to see that we have not produced for you, feel free to let us know about it. That's a pretty long forward link there, which I'm not going to try and pronounce, but you can go to the File menu. As was mentioned earlier, go to the File menu and select Print to PDF. That will give you a local copy of these slide decks, and you'll be able to work from there. Today's webcast was presented using Microsoft Office Live Meeting. It's a great collaboration tool, especially if you have a remote office or remote employees that you work with. If you would like to give it a try, they are offering a 14-day free trial at www.microsoft.com/presentlive. All right, so I'm going to go ahead and put that evaluation up on your screen. The screen that is loading now is a live web page. So when it does come up, you will see two central blue links on that screen, and those are the links that will launch the evaluation within your live meeting browser. One says registered online, the other one says all other registrants. If you click the registered online link, it'll bring up the evaluation about half filled out with information you gave us when you registered for this webcast. If you prefer to start with a completely blank evaluation, you would want to go to all other registrants, and that will give you one that's completely blank, and you can start from scratch. So I'm going to go ahead and leave this up on the screen. Thank you in advance to those of you who do take a moment to fill it out. We really do appreciate your feedback. Guys, if you'd like to take it away and go through those questions, please do so now.
Yeah, I really appreciate it. I think it's important to try to get most of the questions answered here. Jeff, three I had recorded from earlier when you were on a roll and I didn't want to interrupt you. Is there a standard set of questionnaires to gather clients' requirements?
Standard set of questionnaires.
Something like maybe out of the Patterns and Practices group?
Yeah, there's also guidance that you'll see in the Visual Studio Team suite that'll also give you some information around that. There's a project portal that gets set up when you start a new project with like Team Foundation server that has guidelines for requirements. The real answer though is it depends. Unfortunately, I have to give you that answer because every different case is unique. But there are general guidelines in terms of how to define, vision, scope, requirements, etc. So there's quite a few resources out there on the net, and definitely within Visual Studio Team Foundation server.
Yeah, and we had a similar question on is there any standard template for gathering requirements, task management, changes in requirements? Pretty much the same answer.
Yep.
All right. One other question here. You mentioned denormalization. How often do you go beyond third normal form and denormalize? And how do you convince the staunch third normal form it is the only proper normal form theorists, most of whom don't even know that normalization go way beyond third normal form? I've heard up to 19 levels. They'll never have gone that far myself. Any comments on that one?
So this is based on some experience I had in doing some data warehousing applications in the past, and the key for providing the best information around it is typically a performance test. So what I mean about not denormalizing your data, sometimes it is better to have data redundant in more than one table, depending on the queries that you're doing, for a faster response time than trying to keep everything as denormalized as possible. So, it's a guideline in terms of when it may be used, and typically it's in the data warehousing space, where you may need to return a query that it's easier to have that data in the existing table than try to link to it in terms of getting a faster response time. So a lot of times it's not the answer that you would be looking for, but it goes against what DBAs have been taught all along. And the best way to prove it out is in a performance test.
All right, some other questions/comments here. These are all in the question manager queue. How could a part-time architect possibly meet the requirements of the MCA?
So in the MCA program, if you do enroll, what you find is you'll be assigned a mentor. And that mentor will provide you with tasks and study work, etc., to go through to make sure that you get the experience and background that you need to be able to successfully pass the test. There's also organizations like the IASA, International Association of Software Architects. They can also provide some guidance in terms of, some things you would need to know in order to pass those tests. And a lot of times it's just a matter of trying to get as much real-world experience on different platforms and technologies as possible to get the skills that are required to pass it.
All right, you really invoked a lot of hearts and souls, Jeff, during this session. I could tell you, have been a lot of great comments like this one here. Looking for your thoughts. How do you tread and handle organizational politics apart from trying to do the best job you can and playing a good team member? Sometimes it's got not good enough. Some team members seem to be to be detriment to the team, which management neglects to do anything about. So any thoughts on that one, Jeff?
So that's tough to answer explicitly. What I'll do is tell you that this is a very soft skill that you need to work on to be able to identify who your stakeholders are, what is most valuable to them, what are they looking for. There's a good book out there called Leading Geeks, and geeks used as a good term, not a bad term, but it talks about a lot of the psychological aspects of the IT industry and who the players are and what the ways of motivating different people and communicating with them are. So it's hard to give hard and fast guidelines around politics, but I would encourage you to, basically study your environment, understand what motivates other people, and figure out what things aren't taken for granted on the surface to be able to understand what the underlying politics might be.
Great. And by the way, I had several comments along the way that folks want to see a dedicated webcast series to design patterns. Is that something you'd be up for, Jeff?
Something we could look at in the future, absolutely.
All right, that sounds good. Hey, another question here from Pierre. How do you integrate architect model with existing apps which are needed to run daily ops generating revenues?
So I'm assuming that's an existing application that's already in production that needs to run daily. So it's almost like, how do you re-architect something that's in production?
Right, yeah, that's how I would read that.
So reverse engineering comes into play there in terms of dissecting what components are there, how they're put together, creating a reference model and documentation that supports that. That's how I would do that.
Okay, I would like to register for the Web Service Factory Webcast. Thanks. Okay, good comment. Yep, we'll see you on there for that one. Just go out to my website. And then, again, why don't you start A to Z of software architecting hands-on lab with sample project for the sake of upcoming architects. So a lot of interest there, Jeff. And then a follow-up question here from Ben on the MCA question. So I'm currently working on my MCSD certification, and noticed the MCA program. Basically, when is a good time to request a mentor after such certification and understanding, or right now while I'm in the learning the ropes?
I would do it after certification. A lot of times they're going to look to see if you have the certifications as part of the process. So I would put it down later in the process. Go for the individual certifications first,
all right,
and then look longer term at the MCA.
And who's the author of the 4 Leading Geeks? Any idea there?
His name is Peter Glenn, and if you ever get the chance to see him in person, he's actually a very great speaker, and his book is very good as well.
Okay, of the Agile methodologies, could you capture and elucidate the essence of these methodologies? Probably
best for a follow-up webcast, since we're out of time. But I think what we'll do is come back with some of the prior recommendations around the A to Z of software architecting that we go into depth on those methodologies.
I just posted all over link for that book. So, yeah, I think we're in great shape here. Jose mentioned where's the Code Camp announcement. I did make that, so we're all set there. And I think we're good. Jeff, thank you very much, sir. And is there any other parting words you want to say to our crowd?
No, just want to say thanks for everybody attending. I appreciate it. Hopefully it was insightful. Hopefully you got a better respect for what an architect does rather than just draw pictures on a whiteboard. I know it was a lot of material and content. However, my goal was to give you a view into the depth and breadth of what the role entails and how to be successful at it. So thank you for attending.
Mission accomplished there, Jeff. Thank you once again. And John, we'll turn it back over to you. Thanks, everybody.
Gentlemen, thank you so much. Really appreciate the excellent webcast today. Ladies and gentlemen, also really appreciate you coming online. Thank you so much for joining us for our webcast today Again, there is another Russ and Joe Developer Show coming up, I think, is that at noon, guys? Noon Pacific?
Noon Pacific, yeah. It's at 11 Pacific. It'd be 2 p.m. Eastern Standard, right, Jeff?
Yep, we're on in 40 minutes.
Great. And just for your convenience, ladies and gentlemen, if you do want to see that, in just a moment I will post a link to register for that in the question and answers pane, so that'll be coming up in a few minutes. Wanted to thank everybody for logging in. Really appreciate it. Thank you, those of you who have taken time to fill out the evaluation. We really appreciate your feedback. For now, this will conclude the audio portion of this webcast. Look forward to seeing everybody online, hopefully later today. Take care, everyone.